So let's take a look at what logs do and how they operate by going through several examples. First of all, what I've got here is a log with a base of 3. So this is called the base. And it has an argument. This number here is called the argument. So a little bit of vocabulary before we start. So we have a log with of base 3 and an argument of 9. And what is that equal to? So what you have to imagine is, I'm just going to erase those circles there. What you have to imagine is what number would I put here in the exponent of 3 to get the argument of 9. And hopefully you can see that 3 squared equals 9. So the exponent that I'd have to put in is 2. So the right side of the equation is actually the exponent. So let's try that again. This time, imagine what you would put right here on the exponent of 5 to get 125. And the answer is 3. Why? Because 5 cubed equals 125. So I've got the next example here, which has got a fraction in it. And again, you imagine, what do I put right here to figure out 1/10? And the answer is -1, because 10 to the -1 is 1/10. All right, now let's deal with square roots. And when you're dealing with roots, my recommendation is that you always change your radicals to a power. So square root of 6 can be written as 6 to the 1/2. Now I ask, what do I put in here to get this argument? And it has to be a half. So in this case, log of base 10 with an argument of 95. If I put a 1 here, it would be 10 to the 1, which is 10. And that's too small. I want 94. And 10 to the 2 is 100. So there isn't a whole number that will work. It will be something closer to 2, because 10 to the 2 is 100. So what you can do is you can enter this into your calculator. And the log of base 10, which is called the common log, is actually one of the only ones programmed into your calculator. So log of 94. The common base of 10 is understood, and if you calculate that out using your calculator, you should get 1.97, which we expected. We expected it to be close to 2. So now I want you to stop, maybe pause the video, and think about what the answer to this next one would be. And hopefully you I assume you're going to be having a few troubles to find an exponent that will give you a negative number. And remember what exponents look like? The basic graph is like this, and it never goes into the negatives. So the argument can never be negative. This is undefined. In other words, the argument has to be bigger than 0 in order for the log to exist. So let's scroll down here and do a couple with variables. What number do I put in here to get x to the 4th? The answer is 4. And one more. Log of base 3 with an argument of 6. So 3 to the 1 is 3, and 3 squared is 9. So it's got to be somewhere between 1 and 2. And unfortunately, base 3 is not on your calculator. So only base 10 and base e. And e isn't something we're going to be looking at in this course, but log of base 3 is not on your calculator. So I'm going to introduce to you a method for calculating logs that are not base 10, and that you can't just do by inspection. So it's called the change of base formula. And it looks like this. If you have a base that you don't want or can't use, then you can change it to any base you like. It could be base 10, it could be base 2, it could be base 5, any base you want. And the way you do that is using this formula. So here is my new base, and I've got an equation that's got a log divided by a log. That's actually the only time you'll see a log divided by a log is when you're applying the change of base formula. So here I've got one that I don't want because I can't calculate it, so I'm going to change it to a base of 10. It will be log base 10 of 6 and log base 10 of 3. Just straightforward application of this equation. And base 10 is common, so we usually don't write the base 10. And now I'm just going to enter that in my calculator, and make sure that you close the bracket. Your calculator will often put a bracket here. Make sure you close it before you do the division. And so you end up with 1.63, which is what we expected. We expected a number between 1 and 2. So logs are an alternative to writing things in exponents. So if I go back to this example right here, you have two equations, the one in yellow and the one in green, and they provide the same information, they just do it in a different way. So that means that you've got a little bit of power to solve questions using one or the other. And that's what the rest of the chapter is about.